This is the second part of the chapter on circles. Exercise 17, question number 2. In the given figure, O is the center of the circle. This is the figure given. Okay. O is the center of the circle. Angle OAB and angle OCB are 30 degrees and 40 degrees respectively. Means angle OAB is 30, OAB, this much is 30, and OCB is 40, OCB is 40. Find angle AOC. AOC. Let's mark the angle that we are going to find. Angle AOC. That one. Okay, I'll just write which is the angle which we are going to find. Angle AOC. This angle AOC is actually made at the center. Middle alphabet shows where it is made. Okay, so this angle is made at the center. And the first alphabet and the last alphabet shows which arc makes it. So AC is the arc which makes it. Okay. AC is the arc which makes the angle at the center, that's O. This is what you're going to find. So to find this, according to the first theorem, it says angle made at the center is double angle made on the circumference. So you see which is the angle made on the circumference by the same arc, which is the arc AC. So which means that angle should start with A, end with C. Is that right? That's the arc which should make it AC. And the angle should be made on the circumference. Now, which is the angle made on the circumference? It should start with A, end with C. A, B, C. This. If you know this, you can find this. This should be A, B, C. That's the angle on the circumference. So angle at the center will be double angle on the circumference. So if I know the angle on the circumference, then I can find the angle at the center. So there are only two angles which are known. One is 30, one is 40. So to find this, what I am going to do here is divide this figure into two parts. So I am going to draw a straight line from B to O. Dividing this figure into two smaller triangles. One triangle is here, one triangle is there. Two triangles. Okay. Now look at the first triangle, this one, this triangle. For this triangle, O to A is called radius, O to B is also called radius. If both of them are radius, they should be equal. Okay. So OB and OA must be equal, which means this triangle becomes an isosceles triangle. Two sides are equal, so it becomes an isosceles triangle. If it is an isosceles triangle, two sides are equal, two angles also must be equal. That is, this angle and this angle should be the same. Which means if this is 30, this also must be 30 degrees. Okay. So you get this angle is 30 degrees. Why? Because this side and this side are equal. It becomes an isosceles triangle. These two sides are equal. Angles opposite to them also must be equal. These are the two angles which should be equal. So if this is 30, this must be 30. Okay. So I have written the first one. In triangle AOB, this is the triangle which we took. Angle ABO, that's this, is equal to angle BAO, this one. These two angles must be equal. Both must be equal to 30 degrees. The reason, since AO and BO are equal. Two sides are equal, which means two angles also must be equal. That's for the first triangle. Let's go to the second triangle. In the second triangle, OB is the radius, OC is also the radius, which means they should be equal. So this and this must be equal. So this triangle also becomes an isosceles triangle. Two sides are equal, so it is isosceles. Two sides are equal means two angles also must be equal. These two angles must be equal. If this is 40, this must be 40. So that will be 40 degrees. So statement for that. in triangle COB, the second triangle. Angle CBO, that is this one, must be equal to angle BCO, that is this one. Both are equal to 40. Reason, since BO and CO are equal. Two sides are equal, therefore two angles are also equal. So you got both of them. This is 30, this is 40. Okay. But you are supposed to find angle ABC. To find AOC, you have to find ABC. ABC is this whole thing, which is made of two parts, 30 and 40. Add both of them together. So ABC, the total angle on top, is made of two angles, ABO and CBO. ABO was 30 and CBO was 40. No reason for this. This is just simple addition. Add these two together, that will give you 70. So these two added together gives you 70. So you know that this angle is 70 degrees. That's the angle on the circumference. But you are supposed to find AOC, angle at the center. Angle at the center must be double of whatever is made on the circumference. So double of 70 is 140, that will be this angle. So the last statement is angle AOC, which you are going to find, which is at the center, is double angle ABC. This is the angle on the circumference. Reason, angle at the center is double angle on the circumference. So that gives you 2 into ABC is 70, that is 140 degrees. Next question. Question number 4. In the adjoining figure, this one, AC is the diameter of the given circle. AC is the diameter, you can see it passes through the center, so this is the diameter. BCD is 75. BCD, this whole thing is 75. Calculate the size of number 1, A, B, C. We'll come to the second one later. A, B, C, this one is what you have to find first. Okay. So that's the angle that has to be found first, that one. Since this is the diameter, this figure is a semicircle. According to the third property of circles, angle in a semicircle is a right angle. Means angle in a semicircle, this angle will be equal to 90 degrees. Nothing much you have to find. So first statement, angle ABC is asked. ABC is equal to straight away 90 degrees. Reason, angle in a semicircle. This one. This is the angle in a semicircle. That should give you 90 degrees. So this is found. Second question is you have to find EAF. EAF, which is outside the circle. Okay. So to find this, you have to know this angle. I'll mark that. That one. To find this, you have to know this. Why these two angles are vertically opposite angles. But this is not known. But to find this, you have to know this. Why? Is A, B, C, D. This four-sided figure, which is a quadrilateral, is actually called a cyclic quadrilateral. Because A, B, C and D all lie on the circumference of the circle. So about a cyclic quadrilateral, opposite angles of a cyclic quadrilateral are supplementary, means they add up to give you 180 degrees. So if this is known, you can find this, because they will add up to give you 180 degrees. So our next statement is, if you add this and this, it should give you 180 degrees. That is angle BAD, that's this one, plus angle BCD, that's this one, should give you 180 degrees. Reason, opposite angles of a cyclic quadrilateral. BAD is what we are going to find, this one, plus BCD is 75 is equal to 180. Shift the 75 that side. BAD is 180 minus 75, that gives you 105. But the actual question is to find this. Since you know this, you can find this because they are vertically opposite angles. So our next statement is angle EAF is what you have to find, this one. is equal to angle this one, that is BAD. Reason, vertically opposite angles. So EAF is equal to BAD is 105 degrees. Okay, the last question, question number 6A. Find the unknown angle. Give reason for each step in your calculation. This is the figure given. You have to find the unknown angle. The unknown angle is here, that's x. There is one angle which is known, that is this one, this 240. Okay. Now, if you have to name this, this angle will be AOB, this one. And if you have to name this angle is also AOB. But there is a difference between the one which is below and one which is above. The smaller angle is angle AOB. This one is the smaller angle which is AOB. The bigger angle, this one, is called reflex AOB. It's called reflex angle AOB. This is AOB, this is also AOB, but the smaller one is named as angle AOB, this one. And the other one, the bigger one, is called reflex angle AOB. Now to find x, it's better I find the lower angle here. Okay. Because I know this, let's find this angle. The sum of angles here is 360, that is angles around a point is 360. So if I add this and this, it should give you 360. For that, the first statement is reflex AOB, that is this, reflex AOB, plus angle AOB, that is lower one, gives you 360. Reason, angles around a point. So, on adding both of them, reflex AOB is 240 plus angle AOB is what we are going to find, equals 360 degrees. Shift the 240, that's it. Angle AOB is 360 minus 240, that gives you 120 degrees. This is found. Okay. Our lower angle, this one, is 120 degrees. And if you look at this triangle, OA is the radius, OB is also radius, both should be equal. Which means this triangle which is here is an isosceles triangle. Two sides are equal. Angles opposite to them also must be equal, which means this and this should be same. If this is x, this is also x. And if you add all these three angles in the triangle, it should give you 180. So our next statement, this and this are equal. Angle OAB, that's this one, is equal to angle OBA, that is this one. Both are x. Reason, OA and OB are equal. Two sides are equal. Now adding all the three angles. Angle AOB, this is the first angle, plus OAB, that is the second angle, plus the third angle is OBA. All added together should give you 180. Reason, sum of angles in a triangle. So add these, that is AOB is 120 plus OAB is x, OBA is also x, is equal to 180. Shift the 120, that's it. X plus x gives you 2x is equal to 180 minus 120, that gives you 60. So x is equal to 60 divided by 2, that gives you 30 degrees. That's the unknown angle. And your homework, exercise 17, question numbers 1, 3, 6, subdivision B, subdivision C, subdivision D and subdivision F.